You are performing a two-tailed matched pairs test with 23 pairs of data. If alpha equals 0.1, find the positive critical value to 2 decimal places. So what we just read is that we are performing a matched pairs test, and that first phrase, or, yeah, I guess you could call it a phrase, is key because knowing that it's a matched pairs test tells us that we are using the student's t-distribution as the sampling distribution. So I'm going to put here student matched pairs t-test to remind us that we're going to be dealing with the t-distribution. Next, we want to notice that it says two-tailed. Okay, so maybe we could even do this out like t-test and two tails, and then it says with 23 pairs of data, so n equals 23 pairs of data, and alpha is given as 0.1. And now when we said two tails, that means that is the total alpha in both tails. All right, so when you draw out your t-distribution, when you start thinking about doing what they've asked us to do, which is to find the positive critical value, we need to envision it. Well, let's draw it. Okay, here's our t-distribution, 0 in the middle, and on each side is going to be a negative critical value and a positive critical value because this is a two-tailed test. So we have some area on both sides. And our total alpha is 0.1, so that would mean that on this side, half of the alpha is 0.05, half of 0.1, and on this side, the other half of alpha. And that's important for when we try to figure out what our critical value is, because we have to look up an area and then find the boundary for it. So using Excel to find your critical value, which is a t-score, and it has to be positive, so we're going to put absolute value on the outside. Then we're going to use the t.inverse function, and it says for one tail or for two tails. Now you can use the two tail and just put in 0.1 and it should do it for you fine, or I usually just teach students to learn how to use the just one function because things can get weird and confusing if you're dealing with more than one function. It kind of depends on what makes sense to you, but I like to always just use the regular t inverse and draw a little sketch so I know what area to put in. So if it's two tails, I need to split up my alpha. If it's only one tail, then I keep my alpha totaled. All right, so here I'm going to put in my probability, which is 0.05. And the degrees of freedom is always one fewer than your sample size, so n minus 1 degrees of freedom. So this will be, since we had an n of 23, our degrees of freedom for this example is 22. So that's how we got that. All right, so I'm going to put that in, rounded to 2 decimal places, 1.72. Let's look at another version. This time it says right-tailed. All right, so now that it's right-tailed, we need to draw a new picture. And what has really changed, we're still using the t-distribution because we're still doing a matched pairs test. So we still have the bell curve with 0 in the middle. These are t-scores along the horizontal axis. And this time I'm doing a right-tailed test, so I only am going to have one critical value on the right, and the area is going to be all of alpha on that one side. So alpha here, they told us again 0.1. It can change from problem to problem. For whatever reason, it didn't on this one. However, the number of pairs did change, so let's go ahead and fix that. Still have 0.1 alpha. 0.1 is all on one side this time. So I'm going to do the same thing, but I'm just going to put in 0.1 and in place for my probability in the t dot inverse function. So that's 1.32. Didn't like that? Why not? Oh, because I forgot to change my degrees of freedom. Remember, 13 minus 1 would be 12. All right, so 1.36 should be the answer. Okay, shall we do another one? This time it says two-tailed. Let's try another. Two-tailed, two-tailed. I'm looking for one that's left-tailed. Okay, here we go. Here's a left-tailed test, right? And we can see that the number of pairs is 13 again. Alpha is 0.025, so let's change that. And now I have a left tail, so let's change the image or drawing or sketch here. Instead of having alpha on the left, it's going to be all over here. Well, I said that backwards. Instead of being on the right, now it's going to be on the left, and it's 0.025. And our t-score, since it's to the left of 0, is going to be negative t. So I'm going to do almost the same thing, but since I don't need it to be positive, I don't need to put the absolute value on the outside because I do want a negative value this time. So I'm just going to do t dot inverse with a probability of 0.025, and n minus 1 is 13 minus 1 is 12 degrees of freedom, and round that to 2 decimal places, so I get negative 2.18. Okay, now if you are not using Excel, you may use a function that's built into your calculator. Of course, I don't teach how to use the calculator for this course, but I'm sure you can find a tutorial very easily by just Googling or doing it on YouTube, how to find a t critical value in, and then put your model of calculator in. But also you can use a table. So if you're not using a calculator at all, you could still look up the critical value using the t table. And so in our reference packet, it looks like this. Depending on what kind of textbook you're using, it can look different, but should be a similar setup. So you can see you have the degrees of freedom along this column. And across the top, you have either a confidence level you can look up, or in alpha in one tail, or an alpha in two tails. So this was the one we just did, was a left-tailed test, so that means only one tail. So I would be looking up for 0.025 in one tail. So I would stay in this column and then match it up with 12 degrees of freedom. So notice that here I was able to look up my critical value to be the same result as I had calculated using the Excel. But notice that in the table it doesn't give you the sign. It only gives you the absolute value of the critical value. So that means that you have to pay attention again to whether or not it's left-tailed or right-tailed or two-tailed even. Just pay attention to how that's stated because it does change your answer from problem to problem.